Hi, welcome to MooMooMath. Today we're going to talk about parabolas. Now, parabolas are the set of all points in a plane that are equidistant from a fixed point, and that fixed point is called the focus, and a fixed line, which we call the directrix. So in this graphic, you can see we have a point that's coming down and a line, and every point on the curve is equidistant from both the line and the point. So if you were to stop this in time, I can't stop it, but you would say this distance is equal to this distance, and it falls right there on the curve. And that's what we talk about, equidistant from both the line and the curve. So we're going to look at two different equations. In Algebra 1, typically students learn about parabolas or quadratics, and they are y equals x squared. Well, this is pre-calculus, and so we are going to look at two different forms of a parabola. We're going to look at what we call an up-down facer, which is what the kids traditionally learn. So that's what this one is, the up-down facer. And the second one is the y squared that they probably have never seen before. Okay, the form of the equation is just x squared is equal to 4py, or y squared is equal to 4px. What you want to do is you want to isolate the squared term, bring the coefficient over to the non-squared term. That's going to be standard form, and this form is when we have the vertex at the origin. So there's nothing added to x or added to y, or added to x in this form. Now, a couple key points. P is the distance from the vertex, so the vertex to what we call the focus. So vertex, and I'm not very good at writing with the smart board here, to the focus. That's a little better. It's been a while since I've done it on this keyboard because I'm literally doing it with a mouse. Okay, the focus is that point. So it's the distance from the vertex to the focus. That is P. 4P has a special name. It's called the lattice, L-A-T-U-S, lattice rectum. And it is the distance across the parabola through the focus. And we're going to draw this in a second. But let's go ahead and define what those two represent. So what we're going to do, what we can see in the formula is this 4p. So we can see the length of the lattice rectum actually sitting in the formula. Then we're going to divide it by 4 to find p by itself, and that's going to be the distance we need to draw the curve, which is from the vertex to the focus, okay? And that is, this lattice rectum is the distance across the parabola at the focus, or the foci if you have more than one, which we will as we're looking at these conics. Okay, so here is the equation for a parabola that is off the origin. And notice it's just the same, only we're adding a shift to the x-coordinate. So instead of just being x squared, it's x minus h squared. And then we're subtracting k from y, or y minus k. And the same thing, but notice the k goes with the y, and the x goes with the h. Now, P, remember, is the distance from the vertex. I'm just going to put vertex to the focus. We just learned that a second ago. 4P is called the lattice rectum, which is a distance across the parabola at the foci. But H and K, H is the new part. H is the x-coordinate of the vertex. It is the x-coordinate for the vertex. So when we're looking at it, we're going to see like x minus 2. Okay, so what we're going to do is we're going to take a positive 2, because notice it's x minus h, so you're subtracting that quantity. And then what do you think k would be? Well, it makes sense. K stays with the y, so it is the y coordinate of the vertex. So HK is the vertex. Okay, so let's look at these in context here. Okay, whoops, we're not quite ready for that. Let's look at this. Okay, let's say we're trying to define some of these things with our quadratic. So the first thing we want to do is isolate the squared term. Well, we have a y squared on this one. So let's move the x to the other side, which will make it a negative x. So negative 2y squared is equal to negative x. So y squared is equal to 1/2 x. And that becomes a positive, so we have a positive. So let's define some things. We need to define the vertex. Well, there's nothing being added to it, the x or the y coordinate. Therefore, the vertex is at the origin. It was the first form that we looked at. Y squared equals 4px. Okay, 4p is 1/2, which makes p really small. It's only 1/8. Okay, now it's going to be kind of tricky to graph this, but we're going to change our scale a little bit to help us. Okay, now y squared. I didn't really talk about this back here, so let's go back for a second. X squared equations face either up or down. Those are the ones we learn in Algebra 1. X squared is a quadratic facing up, and if the coefficient 4p is negative, it's going to face down. Y squareds, though, they are what we call left-right facers, either left or right. And they're going to face right if 4p is positive, and they're going to face left if 4p is negative, or just p is negative. Either one, you can solve for p. So let's go back and look at this one. Our p right here is positive. Okay, it's also y squared. Therefore, it's going to be either a right or a left facer. But because p is positive, it's going to face to the right. So I'm going to place my vertex here, and I just know, I'm just going to think in my mind, well, it's going this way, right? It's going to be a right facer. Now, let's get exact points. So I'm going to change to red for a second so we can get exact points. Okay, I'm going to make this 1/4, 1/2, 3/4, and 1, just to make it easier since our p is so small. Okay, that means our scale is going to be basically in eighths. So 1/8, 1/4, 3/8, 1/2, 5/8, 3/4, 7/8. This is going to be 1. Okay, and the same on the bottom. It's going to be 1/4, 1/2, 3/4, and -1. Now, this should be easier to graph because we're kind of like zoomed in. Okay, so we have our vertex at 0, 0. We know it's a right facer. Now, this is how we count this whole concept of p. Okay, what we're going to do is we are going to go over to the right 1/8. Well, we said this first mark is a 4th. So we're only going over 1/8, which is right here. Okay, that I'm going to label F. That's our focus. Then we're going to go up and down half of 4p. So I'm going to go to 4p, and I'm going to divide it by 2. So when you divide half by 2, you get a 4th. Okay, I'm going to go up 1/4. Well, that's up to here because we mark these in fourths. And we're going to go down a 4th. Well, that is where my curve actually goes through, are those points. Okay, so I actually had it kind of estimated correctly. Now, this whole concept of the directrix. Let's talk about the directrix. The directrix is a line that helps define the points on the curve. So the directrix is also p, the distance of p away from the vertex, just like the focus is. So I'm going to go back 1/8, and right back here is what we call the directrix. So I'm going to dash it because it's actually not part of the curve itself. It is a reference line that defines the curve. So how can I define this line? Well, it's a vertical line, so I'm going to call it x equals. And what did I do? This point where it's crossing the axis is at -1/8. Because my focus is +1/8, so I'm going the opposite direction, -1/8. And that is the equation for my directrix. Okay, those were kind of small numbers. So let's try another one. Okay, let's try this one. Okay, this time we're not given an equation. We're given just some information. We have a vertex at 2, 5, 1, 2, 3, 4, 5. We have a focus at -2, 5. Okay, so here's our focus, and here is our vertex. Now, we can write an equation for this, right? We know at this point that our parabola must face to the left because our focus is always inside the curve. We can also figure out what the distance of P is. We can count from the vertex over to the focus. So 1, 2, 3, 4. So P is equal to 4. Okay, that means my directrix goes back 4. 1, 2, 3. It's going to be right here. Okay, again, I'm just tapping a little line along here. That's my reference line, and our graph's really not big enough for this, but we can still do it. So where does this directrix land? Well, that's at +6. So if I'm asked for my directrix, it's x equals, because it's a vertical line, +6. That is my directrix, and it's down here somewhere. So we know what P is. We've got our vertex, and we've got some information to help us get this graph. Now, in my equation, I need to write 4P. So I'm going to do 4 times P. Okay, so we've got an equation for the directrix. We're solving for 4P, and 4P is equal to +16. Okay, but P is actually not positive, it's negative because we're facing to the left, and so that makes our 4P equal to -16. Now we need to choose an equation. This is a left-right facer, so I'm going to use y minus k quantity squared, and the reason I'm using the one with k is I'm no longer at the origin. My vertex is up here at the point 2, 5. And then 4P, and I'm going to have x minus h. Now, that's my choice of my equation because it's a left facer and it is not at the origin. Now, we found the value of P. We said P was -4, and the reason it's -4, we're going from the vertex to the left 4 steps. If we went to the right, it would be +4, but it's -4. So for the equation, we need 4P, so we're going to use that -16 in the equation. Now let's plug in H and K for the, or this one's H and K for the vertex, and we're going to plug in the value for P, and then we'll have our equation written. So we're going to do parentheses, y minus k. Well, let's go back and define what k is. K is the y coordinate of the vertex. So we're going to plug in a 5 right here. We're going to square that, and it's going to be equal to -16 x minus 2. And there's our equation. Now, to actually graph it, I can now use the fact that I have the focus. I can now go down 8. Now, where am I getting 8? Remember, we have 4P is the length of what we call the lattice rectum, which is -16. Now, to count that, we're going to take that 16 and we're going to divide it by 2 to get 8, because that length is going to be 16. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. And this point right here is a point on the graph. Then I would go up 8. Now it's going off my graph. That's okay. You can see that I would then go from the focus up and I would count up 8. And there is how I would graph my left-facing parabola. Hope this video was helpful teaching you how to graph parabolas in pre-calc.